Vanakkam, I am Krishna Kumar, Department of Mathematics. This is the last class video, the CSR November 2020, the exam on conducted 30/11/2020. In particular, two states, Tamil Nadu and Pondicherry. So the questions are now discussed. So this is the last class problem, the last two-digit problem. So we are getting the answer 67. Now this one also. CSIR November 2000 asked one. So very important question. Very easy also. This type of problem. The part B. So 3 marks awarded for this question. So very interesting problem this one. The question is limit n tends to infinity n plus 1 into n plus 2 and so on n plus n whole to the power 1 by n whole divided by n. So this 1 by n for this only, not for this. So 1 by n is equal to, the four options are given. The first one is equal to e by 4, then second 4 by e, third option e, the last one does not exist. Let us solve this problem. So before solve this problem, we know about the Cauchy's theorem on limit. So very important one, Cauchy's theorem on limit. So what is the statement? If the n is a sequence such that an greater than 0 for all n belongs to n, capital N, natural number, limit n tends to infinity an plus 1 by an, which is equal to L limit. Then limit n tends to infinity an whole power 1 by n equal to L. So why I take this theorem, Cauchy's theorem on limit? Because the problem is of the form. Is it right? Limit n tends to infinity whole power 1 by n. But we have to adjust here because an whole power 1 by n. But here only n plus 1, n plus 2 and so on n plus n whole power 1 by n divided by n only. So this can be written as like this. So this is a given problem. I write down as it is. Okay. So to bring this form, that is whole power 1 by n. So for that, here we are going to adjust this term, this one, n power n. So this can be written as like this. Limit n tends to infinity. This one is numerator as it is, n plus 1, n plus 2, n plus 1 into n plus 2 and so on, n plus n whole divided by. This one can be written as n power n whole power 1 by n. Is it is? So this one can be written as like this. So why you have to write this? Because of this one. Is it right? Okay. So what we have to find out? This one, that is limit n tends to infinity an plus 1 divided by n. We have to find out, we get the limit L. So this is same as to this one. Okay. So very important. So please note down this, the Cauchy's theorem on limit statement. So using this one, so the problem is on the form. So then you have to limit n tends to infinity, we have to find out the an. This is nothing but an. Is it right? This is nothing but an. Okay. So we have to find out an plus 1, then divided by an, then applying the limit n tends to infinity, we get some limit L value here. Okay. So please note on this. So next. So last page we have seen. So an is nothing but n plus 1, n plus 2 and so on n plus n by n power n. Is it right? So this one we are going to take a, so an, so a suffix n. Okay. So what we have to find out? So before that, this can be written as like this, that is n plus 1, n plus 2 and so on. So what is the last term? N plus n. What is the before last before term? N plus n minus 1. Is it right? So this n means this is n minus 1. Then what about the before term? N plus, this is n minus 1 means this is n minus 2, like that. So like n minus 3, n minus 4 and so on to 1 up to this. Is it right? So this one can be written as like this. So that is very important. Please note on this. Then as it is n power n, now we have to find out an plus 1 because of this Cauchy's limit. an plus 1 we have to find out, that is replace n by n plus 1. So for that, instead of n, replacing n plus 1, then plus 1 for this n plus 1 plus 2 and so on. For this n plus 1 plus n minus 2, for this n plus 1 plus n minus 1. What about here? N plus 1 plus n, and moreover the last is n is appeared. So n plus 1 plus n plus 1. That is next. Is right? So all divided by, so replace n plus 1 power n plus 1. Then we are using this one, that is an plus 1 already we found, an already we have this one. So an plus 1 divided by an. So an plus 1. So this is the numerator 1. I take that. That is n plus 2, then n plus 3 and so on. 2n minus 1 and then 1 minus 1 gets cancelled. So we are getting n plus n, 2n. Now what about here? 2n plus 1, then 2n plus 2. Is it right? So n power n. So how to get the n power n? Actually an plus 1 by an. So this numerator n power n bring to the, sorry, this n power n is the denominator 1. So here bring to the numerator. We know this. So all divided by, so what is the an? An is n plus 1, n plus 2 up to n plus n. Is it right? That is 2n. You can write like this, and then 2n minus 2, 2n minus 1 up to 2n into. So what about this one? Now this becomes n plus 1 power n plus 1. Is it right? So in an term only, numerator becomes a denominator, denominator becomes a numerator. We know this simplification, just recall you. Okay, fine. Now the term will be gets cancelled. Before that, 2n plus 2. So which one is the common? 2 is common. Is it right? 2 is common. So I take this number 2. I write this here. Then n plus 1. So that the term n plus 1 I am going to write here without loss of generality. N plus 1, then n plus 2, n plus 3 and so on to n. So what is the before of this before term? 2n minus 2. Is it right? Then 2n minus 1, 2n up to 2n plus 1. Very right. Then into n power n whole divided by. So this one there is no change as it is same. Okay. Now you start the cancel the terms. This term gets cancelled, this term gets cancelled up to, you have to cancel up to 2n, 2n gets cancelled. So what we are getting finally, limit n tends to infinity to 2n plus 1. So where it is? Where it is? Here. 2n plus 1 into n power n divided by, in denominator only the term is n plus 1 power n plus 1. Is it right? So this is a lengthy one. So 2 into 2n plus 1 n power n divided by n plus 1 power n plus 1. Now we have to evaluate this one is enough. So limit n tends to infinity 2 into 2n plus 1 n power n by, so n plus 1 over power n plus 1 can be written as n plus 1 power n into n plus 1. Is it right? Okay. Just I rewrite this one on denominator. Clear? Then into 2n plus 1, 2 into 2n plus 1 by n plus 1 into n power n by n plus 1 power n. Limit n tends to infinity. I take n common from these two terms. So n 2 plus, here you have to adjust 1 by n. So same I am going to take common n only. So n 1 plus, adjust here 1 by n. So the purpose is the n gets cancelled. So there is a main. So into this can be written as 1 divided by n plus 1 power n by n by n. Okay, this one can be written as 1 divided by like this. So can be written as like this one. Limit n tends to infinity. Now 2 plus 1 by n divided by 1 plus 1 by n, 1 by this one n plus 1 whole power n power n. So whole power you can write n. Now this one is as it is 2 into 2 plus 1 by n divided by 1 plus 1 by n. So this one can be written as 1 plus 1 by n. Is it right? N plus 1 by n can be written as 1 plus 1 by n. Is it possible? We know this very well. So one important result we have to apply when applying the limit n tends to infinity. Limit n tends to infinity. Applying this, we are getting e. We know this result very well. So for that we are getting e only. So what about 2 constant? 2 as it is constant. Apply the limit n tends to infinity. 1 by infinity tends to 0. We know that 1 plus here same. 1 divided by infinity. N tends to infinity. Apply here 1 by tends to infinity. That is 0. So 2 plus 0 2. 2 into 2 4 only. So 1 plus 0 1 e. So finally we are getting 4 by e is the correct option. Is it right? So please note on this. So in this problem we are using Cauchy's theorem on limits. Actually 2 theorems are there. So you are using this only. Okay. So please note down this. It's a very important theorem. So using this theorem we can easily find out the limit of this problem. Okay. So what is the answer? Finally we are getting is equal to 4 by e only. So you can take 3 marks. So thank you very much for watching the full video and with your support also. Nandri.